Let's look at another line integral. Here we have a vector field f, 3x comma 8y, and we have the curve c represented by the vector function t comma square root 4 minus t squared, and the parameter domain is -2 to 2. And we see this is just basically parameterization by the graph, where notice when t is equal to -2, we get -2, 0. So we start here and we move in a clockwise direction to the point 2, 0. That is when t is equal to 2, we get 2, 0. So this is parameterization using the Cartesian coordinates as opposed to the usual trigonometric ones. So what we want to do, as we always normally do, is compute the velocity. So here we take the derivative of r of t, we'll get 1, and by the chain rule, we get 1/2 4 minus t squared to the -1/2 times -2t, and of course the 2's absorb, and we get 1 comma -t divided by the square root of 4 minus t squared, which is what we think about in Calculus 1, with there being infinite tangents at the endpoints. And now if we're interested in the line integral of f about c, that is f dot dr, then we basically do the composition. 3x becomes 3t, and 8y becomes 8 times the square root of 4 minus t squared. And then we dot that with dr, that is 1 comma -t divided by the square root of 4 minus t squared dt. Now when we do the dot product, we're going to get a 3t times a 1, which is 3t, and then of course we have the negative radical 4 minus t squared dotted or times t divided by the radical 4 minus t squared with the minus sign here. Now this just illustrates an idea that we basically have a function with a hole in it, and so Riemann integrals are fine with that. It's not an infinite discontinuity, it's just a hole, so there's no problem with this. These absorb as long as we stay away from the endpoints, and we get 3t minus 8t. And then of course that gives us an odd function, -5t, and a symmetric interval, and we learned back in college algebra that that's 0. Maybe you didn't understand exactly why it worked, but that is 0. So interestingly enough, there are certain theorems that we're going to talk about soon that has to do with closed paths, where we're going to talk about conservative vector fields and closed paths and things that are equivalent. So this kind of opens the door to those ideas when we get to them. And we are done.